Amanda Foote.
I'm Maya Umahara.
I'm Shreyas Kalor.
My name is Amy Houlihan.
And we are Team MASA. Our FEDD project topic was the educational computer game. Our game, titled The Eyes of Engineers, was focused around teaching various engineering disciplines to lower grade elementary school students. A central concept behind our game was requiring the player to use critical thinking skills to come to a solution or simply explore their environment. Very few K-12 schools are effective in teaching critical thinking skills to younger students, and we believe this is a concept that should be developed as early as possible. Before beginning any real development whatsoever, we had to set our goal or problem for the project. Our goal for this project was to develop an educational game that would teach a concept a student would not typically learn throughout a K-12 school experience. This game would have to be developed through the Kodu, GameMaker, or Scratch platforms, each with their own benefits and deficits. The game also had to last a minimum of 5 minutes, however up to 5 extra points were available, with each extra minute awarding 1 point. Additionally, the game would have to give the user the ability to interact at least once every 10 seconds. These are both important to outline so that we knew how to set the pace of the game and ensure that there was not too much idle time. When creating our game, having the time constraints available helped us determine how many levels we had to create. Ultimately, this prompt gave our group a lot of freedom towards the concept behind the game, but it was still necessary for us to define the problem before brainstorming ideas to fit the constraints.
Before we started working on the game itself, we tried to formulate detailed ideas during our group meetups. At first, we had more complex ideas as to what our game would consist of and how we would make it. For instance, our original plan was to use GameMaker. However, looking into it and realizing the amount of time we had left ourselves to make the game, we decided that using Scratch would be easiest to understand. Our plan for our actual game was actually more complex at first. Our game explores different engineering fields. At first, our idea for the story behind this consisted of a kid, who would be the player, going around his neighborhood and helping out his friends using different engineering concepts. However, the story-like introduction became hard to execute with the time we had left ourselves, and the constraints of Scratch. In order to remedy this, we changed this idea and focused more on the levels themselves rather than the story behind them.
Once we had our general plan for the game, we thought of possibilities for the levels. We looked through the engineering handbook at the different fields within engineering and considered how each could apply to the game. We narrowed our options down to 8 various disciplines, basing our decision on the game level ideas we thought were most promising. We divided up the levels between ourselves, each taking charge of 2 levels that we had the most interest in. Then we got to work. We watched online Scratch tutorials, created sprites and backgrounds, and attempted to match our scripts to what we intended for the levels. There was some trial and error. There was lots of problem solving, especially when it came to the scripts. It was aggravating when we couldn't figure out why something wasn't working as we thought it would. Personally, the hardest part was figuring out how I could get the game to do something complex having only the finite list of simple commands to choose from. We eventually finished our individual levels and shared them on Scratch, helping each other fix minor functionality problems. Finally, we made our poster, combined our levels into a coherent game, and mentally prepared for FEDD.
We do not have a prototype, which would usually be considered in the evaluation and retesting process of the engineering design cycle. Because we did not create individual prototypes, basically our prototype became the project. This required constant running through the game, fixing code as we went, before each individual level was even finished. Once finished, however, the evaluations had to continue to fix the possible bugs that could occur in the game. The bugs could be anything from a sprite, the individual computer graphic being the wrong color to the sprite not reacting correctly to the command program. As a group, we were able to go over the other levels, helping to spot bugs and possible places for improvement, enabling a constant improvement of the game through going over each other's levels. We effectively prototyped on a much smaller scale, constantly improving instead of creating one giant prototype and working off of that. The retesting while making the game helped create better levels before putting all the levels into one game, so that much of the evaluation after the individual levels was seeing how the level select worked, instead of spending much time on the levels we had already completed. In the and this process of mini prototyping while working on the project helped create a functioning game. Although some bugs are still present, the engineering design cycle helped us create the game through the individual work of everybody. By applying the engineering design cycle individually, we were able to create a more effective product altogether. I think this process of relying on individual work to contribute to the whole is why we were able to get second place at FEDD.
The main aspect of our work ethic we would have changed would be to start working earlier. Although we met up often and formulated ideas, we did not start executing those ideas in our game until we were dangerously close to FEDD. Furthermore, when we did start our game, the work was spliced so that each person would make 2 levels. However, it would have been more beneficial to work together on levels instead of making them separately. Once the levels were made, it probably also would have helped to have tested the game for bugs and have seen how people responded to our game. At FEDD, when people were testing our game, we found some bugs we could have worked out if we had found them sooner.
Here's my advice. Start creating early on. We created pretty last minute. If we didn't, maybe we would have won first place.
My advice would be to get a solid foundation or plan before jumping into development or creation. We had a good outline and discussed our ideas for how the game was going to be set up well before we started the actual programming. I think this played a major role in our success.
While we started planning early on, I would strongly suggest getting right to work rather than simply brainstorming. Try not to assume that the final product will work according to the plan without testing out ideas or experimenting with options first.
Communication is key. From the first meeting, we agreed to meet in person weekly at a set time and knew that we would meet up more frequently as FEDD approached. We also talked a lot about our ideas and made sure that we had a similar idea of what we wanted for our project. This way, the work was divided more evenly and we all agreed with what was going on. This helped us avoid horror stories of other groups who did not get along well due to miscommunications.